Everyone should have gotten that message. All right, we have 7 excellent teams here ready to pitch today, all focused around our theme of energy and environmental technology related work. This you'll see this kind of runs the gamut from understanding how long a battery will live to new methods for extracting scandium and other materials to some really interesting battery technologies. So can't wait for you to see these pitches. We'll be limiting the teams to 5 minutes on the pitching, then giving you 4 minutes for question and answer afterwards, and then moving on. I'm going to be fairly strict about this. You're going to see I'm going to hold up my 1 minute warning. Does it work there? No, I'm going to turn off my virtual background so that works. You'll see my 1 minute warning sign and then a stop sign. This is just so we can keep the event moving as needed. And with that, we are going to kick it off with Thanos from Enactysys, who's going to be our first presenter here today. Lumishield, you're on deck. But Thanos, you're going to kick us off. So share your screen. Fantastic. And I'm turning it over to you for your presentation.
All right, excellent. Thank you so much, Evan. All right. Well, I'm Thanos Karamalidis. I'm coming from Enactysys, and I'm pleased to open the session with our company because the basis for many advanced technologies is the raw materials, and that's exactly what we do here. Enactysys comes from the Greek word to recover and reclaim. And we are devoted to developing, scaling, and deploying novel solvent-free, highly selective separation systems for the extraction and the recovery of critical minerals from large volume industrial waste. Basically, if that is too complicated for you, imagine sophisticated Brita filters, but this time for critical metals and from industrial liquid waste. The reason for doing that is because we lack, the supply chain has been completely disrupted in the US, and that causes many national security problems. The United States imports $53 billion in critical minerals every year, and that is because we lack the domestic production and refining capacity. One comment that I have to make here is that China owns almost 100% of the processing capacity for 35 out of 54 critical elements for the nation. But I think we do have a solution to that, and that is extracting some of these critical elements from the industrial waste. As I said, abundant waste like titanium liquid waste, leachates from fly ash, or bauxite residues combined with conventional engineering, off-the-shelf engineering, basically, something that the industry knows very well for tens of years already, but innovating on the separation side, basically changing the chemistry that selectively extracts and recovers the valuable critical metals from them. Our priority is scandium and for the production of scandium oxide, but we have already started working with other critical elements like germanium for 5G networks, gallium, vanadium for alloys, tantalum for missiles, platinum group metals for hydrogen production, and so forth. The reason for prioritizing scandium is, first of all, because it's underused because of its price, but we do have a solution to that. And the second most important role for scandium in the Department of Defense and other applications is that it offers a boost of the properties of many materials, like aluminum scandium alloys, for example. We know that could be used as a lightweight weldable material to improve fuel economy and range for aviation. It reduces weight without strength loss for armored vehicles, like tanks, for example, because it is this here. And many partners.
Someone's got a live mic in their room. If you just have you guys mute your mics, that'd be great. Thank you.
Thank you.
All right, go ahead.
And many of our partners in Europe that discuss with ship companies, they think that they need to use the scandium aluminum alloys for ships because of the corrosion resistant boost that it gives. The way that we are envisioning deploying our technology is by modularity and scalability with demand. So we can offer a small footprint which will be very low in disruption of any applications and facilities, basically in mine operations, for example. But as the demand in the market of scandium increases, we can add another module and increase the extraction and the capacity. We have proven so far that our adsorbents are at least 40% better than any commercial alternatives. And we can, at least the economic model so far shows that scandium oxides that we are producing are 40% lower at cost compared to China. We have done the minimally viable process already. And we are heading towards to the production of 1 ton per year. What we offer to our suppliers is profit from their waste and no changes to their process and improve sustainability to meet their environmental goals. And to the customer side, we offer the stable Western supply, which is very much in need right now at low cost and scalable with demand. What we are seeking help with is to build this 1 ton per year scandium oxide pilot unit, understand better the needs of the scandium end users in the Department of Defense, and build out connections to Department of Defense contractors. With that, I would like to welcome you to our booth after our presentation and to answer any other questions. Thank you.
Fantastic, Thanos. Thank you. And I will open it up to the room for questions now. Feel free to unmute yourself and ask any questions. If you are in an environment where you can't do that, you can also put a question in the chat here, and I can read it out for the group. So questions?
Have you thought about recycling materials from batteries, you know, cobalt especially, but manganese? You know, there are lots of critical materials that will eventually be part of recycled battery packs from whatever applications, EVs probably more than any other.
Yes, as I said earlier here, our goal is not to just produce scandium, but expand the technology to extract other metals as well. Not specifically batteries at this point, because we see as an easy entry to the market, scandium being one, germanium being next one, and many other elements. Scandium also offers great properties for solid oxide fuel cells, theranostics, and some other applications. But definitely it's in our horizon to do recycling of other critical elements from other feedstocks.
Awesome. Hene, do you have a question?
Yeah. Hey, while you were giving this presentation, it just occurred to me that you and I can partner on like us putting a coating from scandium on aluminum. So rather than making the whole alloy, if we can put a coating with aluminum and scandium oxide, that can be really cool. So I think we should like meet up.
We should definitely discuss, of course.
So I guess just to follow up on that, the question, your answer to the question about recycling batteries, is it that it's so unique in the chemistries that like if you're looking for scandium at the other one, or you know, why are you doing it linearly versus trying to pull out a range of chemicals all at once?
Yeah, that's a good question. I think that most of the separation technologies that exist out there, they try to do all at once and they fail altogether, I think. No, that's probably an exaggeration. It's very difficult to chemically separate some of these elements among themselves because of similarities in chemistry, similarities in size, similarities in oxidation states, etc. Okay. So you need to tailor, at least that's our belief, you need to tailor some of the chemistry to the specific target ions.
Okay. And then is it the vision that it's a stepwise function so that like first it would go through a scandium filter, then it would go through, and then just down the line, is that everything?
Yeah, yes, I think so, yes.
Okay. Thanks.
Fantastic. Well, thank you so much, Thanos. Anyone else, any questions come to mind? Anything you realize that you want to ask? Please visit the Enactus booth in the later half of today's demo day and have a good one-on-one conversation with Thanos about partnering with your agency.
Yeah. Thank you. And obviously, we are going to be waiting you at the booth.
Awesome. All right. Next up, we have Huneya Nuala with LumaShield. Ready when you are. Take it away.
Hello, everyone. My name is Huneya Nuala. I'm from LumaShield Technologies. And before I start, I want to thank you for all of you to taking some time and listening to us. With that, I want to kind of jump into LumaShield Technologies. LumaShield has developed a process to deposit metals like aluminum, magnesium, titanium in water onto different metal substrates. It's a technology where we have currently focused as a pre-treatment to metals to avoid corrosion and make paint adhere orders of magnitude more stronger. It's a validated technology. We have gone through a large scale demo, and currently we are in a JDA with the world's largest steel manufacturer. The key offers we are able to do is to reduce the repair work and provide sustainment. We can improve the supply chain while the missions are critical. I think I also want to bring up the non-toxic nature of this technology. That is, the pre-treatment is not based on chrome or phosphate or cadmium. It's basically based on an aluminum oxide coating. So this is in some data of what we have been able to do. What you are basically seeing is that when we have our pre-treatment, and when we basically put a big giant gap into steel metal, the rust does not penetrate underneath. When we compared this with the industry standard, what you end up seeing is that the rust goes in and you start to have this peeling effect of the paint, and it ultimately causes a failure into whatever you're trying to protect from the corrosion. As I mentioned early on, that we have right now a JDA. We are currently under pilot testing with our technology to deposit aluminum oxide onto steel and steel coils. And that is very exciting to see, something which came out from university and now it's going into the commercialization. And we also want to take our technology and start applying into critical needs in the defense space. So how we are thinking about entering the federal space is basically a technology known as brush plating, where you create a small brush and you are able to coat this thin layer of aluminum oxide onto pretty much any conductive substrate. This is an example of 4,000 hours of salt spray, where you can start to see the failure, which starts to show from the current trichrome coating versus our coating. And from there, we think that we would be able to expand into other areas within the federal space. And the main reason why we are targeting this is there is a push through OTA consortia, through CERDIP and EST-CP, where there is a push to move towards more environmentally better solutions with high performance. Currently, we have identified potential government contractors who can help us in getting this into the government space, as well as we have a development partner, Faraday Technologies. They may be here too, and they are amazing to work with. So we are not going through the traditional JDA route, but we are thinking about entering directly into the commercial space through a contract-based methodologies. And if you have any need where you are looking for repair, we would love to talk to you. I will be in the booth, and I would have to have much more in-depth, detailed conversations with you. I think it's important to talk about the team. This team is heavily technical. That being said, we are in this to not go after research money, but to have a product in the market. I want to point out that we have raised $2.5 million through the federal resources, as well as $1 million in seed through a seed raise. The technology itself took about $7.5 million of research funding to get it and figure it out where we are while we were at CMU. And with that, I want to kind of give you the tagline that we stop corrosion, and I want to solve your corrosion problems.
Fantastic. Thank you so much, Junaid. We'll open up the room to questions.
Hey, Junaid, it's
I should
Mike.
have said, oh,
Yeah, no.
Hey, Mike.
Hey, I just, we've talked about this, but I was just wondering, so there's the kind of applying it to the high value ones you show here, like but also how different is it with in the case study, the pilot you're doing with Tata, how different is the application between the way
They are day and night different application. What Tata wants to do is to put on coil steel for coil production. The example I have is basically which is a sea-based X-band radar, which costed $900 million a piece.
Mm-hmm.
And I'm sure there are hundreds of similar items within the domain, DoD domain, which needs corrosion protection. And if you can improve the corrosion on those things, that can be a significant return to the Department of Defense on maintenance cost. It can also be a significant return in terms of its operability while it's in a situation. So I think, yeah, it's a different approach. One is coil deposition. What we are thinking about doing is through a brush plating unit.
Mm-hmm.
Because I mean, you look at the size of this. This is like a ship. You cannot just dip it in a tank.
Yeah.
That's why it's going to be a completely different technology.
But with Tata, it's still a electroplating, right? It's still going to.
It's also electroplating. Both of them are electroplating. The chemistry slightly changes, and that's why I think it becomes a really good case for dual use.
Okay, awesome. Thank you.
James?
Yeah, I think I heard you mention something about corrosion prevention underwater, and brought to mind, is this a technology that's intended primarily for manufacturing plants, or can this be used in situ repair type situations?
Yeah, so for the federal application where we are thinking right now is for repair applications. This is kind of what we are thinking here. The image on the right is talking, somebody has a brush plating unit and they are repairing it. Right now, what they use is chrome and cadmium to repair. And we can replace it with an aluminum oxide coating through a same electroplating or electrodeposition.
And does that have to be done in a dry dock or in a factory, or can that be done with a smaller unit by a team on site?
It can be done in the field. However, after it's done, it has to be painted and primed and all those things. So I would think that it still has to be brought back. So it's not like, so I think there are additional steps. So yeah, we can do our steps, but I don't know, do they have like portable booths to spray paint and repair and things like those. So I think there is a little bit more, but we are thinking more in terms of depot repair right now.
Fantastic. Well, if anyone else has questions for Junaid, again, I'm going to be a broken record on this, but please join him at the LumaShield booth following the pitch session here. Great presentation, Junaid. Thank you.
Thank you, guys.
All right. Our next team to present today is the team Nimbus AI. Nimbus AI is next. Novum Nano, you are on deck. You're on deck, Novum Nano, so get ready. Nimbus AI team. The floor is yours.
I'm ready. Hopefully you can see my screen.
We
Fantastic.
can see your screen. We can hear you. You're all set to go.
Fantastic. We're good to go. Okay. Well, thank you so much, everybody. Thank you for being here and for dedicating some of your time to us. I'll say good morning from Hawaii. And I would say good morning from Hawaii if it wasn't for all the bad news that we are getting every day. We get bad news about Russia invading Ukraine, terrible news about climate change. Recently, there was a new report from the IPCC that was released with even more grim forecasts for future climate. And if you pay close attention to all these news and to others that I spare you to try not to depress you too much, if you pay close attention, you notice that a lot of these themes have some common intersection. And the common intersection is that, in case this wasn't clear enough already, that energy is important and that most of the some of the most important problems that we face as humanity going forward are related to energy and to energy security. So this can be associated with national security, state of the planet, geopolitical equilibria, and so forth. And we believe that because energy is so important, and because energy security is so important, we believe that a world that relies a lot more on renewables is a cleaner and a more independent world, and something that we should work towards. Obviously, we're not naive, and we understand that renewable sources are subject to natural variability. And if we are to increase our dependency on natural resources, then we need to have a good hold on this variability, understand this variability, and be able to predict the production of energy that can come, variability notwithstanding. At Nimbus AI, there are currently 4 of us, 4 co-founders, and we are a mixture of academics and people who come from the private sector and who have experience in the startup world. I myself am a professor of atmospheric sciences at the University of Hawaii. We have computer scientists and mathematicians as well. And in terms of the products that we are currently offering, there are 2 main products that we are offering. One of them is the ability to do short-term forecasting of solar irradiance. So what I'm showing here is a comparison between a satellite image on the left-hand side of solar irradiance, and the right-hand side is what we predicted using a combination of satellite images and a state-of-the-art machine learning algorithm that we designed. The prediction was obviously made about an hour ahead of time, and you can see that the agreement is pretty good. The slide that I'm showing here is for the island of Oahu, where we are at the moment, but these can be done for any place in the world. And the second product that we are offering is the same sort of prediction, same idea of predicting solar irradiance, but with a little bit more of an horizon. And so the second product is a day ahead forecast of solar irradiance. We recently participated in a national competition to predict solar irradiance, a competition that we won. And this is an example of a product that we submitted to win that competition. The black line shows the values of solar irradiance measured at a particular site, in this case, it's Salt Lake City in Utah. And the shaded areas are probabilities that we associated and that we computed the day before with some algorithms that we designed. In terms of what we are hoping to do with the federal government, well, the Department of Defense is the largest institutional consumer of energy in the world. And I think that this has been discussed for many years now, but it's becoming really clear in the last month and a half or so with the situation in Ukraine and Russia escalating. Thank you, Evan. That I think we can all agree that energy independent military is a top national security priority. What we can do with our methods, we can help military bases, for example, become energy independent or march towards their energy independence by optimizing their PV power production. This could be in terms of managing the resources that they have at the moment, or in deciding where to install new resources in the future. And the second application of our technology that we envision for DoD or for the federal government is that we could provide also intelligence on energy security and especially power production through renewables of foreign and potentially adversary countries. So this was all for me. I think we're all in the 5-minute limit, and I hope to answer many questions and see you at our booth. Thank you so much.
Thank you, Giuseppe. We already have a hand up. Paula, over to you.
And so I don't want to assume, is this pretty Wi-Fi reliant?
This would be Wi-Fi reliant at the moment, yes. Essentially, you'd be able to connect to our website where you could download the predictions that we make. Although we'd be happy to work with our clients to find other alternatives. We could give, for example, we could give you the algorithm that we use to make predictions, and you can make your own predictions on your machine, for example.
But if I had it on my machine, it would still be Wi-Fi. I would still need the Wi-Fi in order to do that, correct?
Not necessarily. You'd need Wi-Fi at times to download the data, yes, but not continuously.
Okay, perfect. Thank you.
Thank you.
Good question. Any other questions here for Giuseppe? I should have mentioned earlier, when I ask if there are any questions, I always wait for 8 seconds to give people actually time to unmute themselves. So we will live in those uncomfortable 8 seconds. Fantastic. Well, if anyone, as always, has more questions for Giuseppe, wants to see some of the materials, you can find them in the Nimbus AI booth at the end of these presentations.
Thank you so much.
Great work, Giuseppe. Thank you very much. All right, next up, we have the team from Novum Nano. On deck is Polu Energy. All right, we can see your screen there. Perfect. We'll turn it over to you, Greg and Craig.
Unmuted. Forgot to unmute. All right.
There we go.
Hello from Mount Rushmore and the beautiful Black Hills of South Dakota. Welcome to Novum Nano. I'm Craig Bailey.
And I am Greg Christensen, and we are here to solve the DoD's problems. So normally Craig will go on for 15 minutes, hours on this. So we got him to do a short video.
Well, let me tell you guys, both of you, about 2 use cases that we have for the nano memristor. The first one is the use of drones in an environment such as the Ukraine currently or potentially. Drones are affected by electromagnetic pulses. If we could create, using an Army partner, you guys, Northrop Grumman, NSIN, Department of Defense, to use a memristor to replace other electronic devices that currently are affected by electronic noise that renders that drone inoperable for a moment, something like having to reboot your hard drive. That would be a huge improvement. The second one is in the use of telecommunications and devices and systems. If there were something like a Russian EMP was set off, we would lose the ability to use cell phones, internet, radios, etc. We could protect that with a nano-based coating and a memristor based on nanotechnology today.
Okay, so we have a patent on this memristor, but what is a memristor? Essentially, it's a resistor with memory. It does not require an external power source. So you cut power and it remembers, whatever you gave it last. This equates to smaller, lighter, faster, more efficient electronic devices, computers. They're more robust. You get fewer components, which is more cost effective. A memristor can replace multiple resistors and achieve, an even more enhanced effect, which results in heat reduction. So you get next generation warfighter support.
So a little bit about the company. We formed Novum Nano in 2019 to commercialize nanotechnology. We did win the South Dakota Governor's Giant Vision Award in 2020. In 2021, we won an innovation award at Defense Tech Connect Nanotech in Washington, D.C. We'll be back there again in June. We partner with South Dakota School of Mines and Technologies to develop and patent this novel technology. We have 8 patents issued. Our intellectual property strategy is to work with South Dakota School of Mines and Technology. We co-invent, co-patent, sign our rights over to the School of Mines, and then we have an omnibus exclusive licensing arrangement to be the only ones to commercialize this technology. So if somebody wants to challenge our patent, it's not just Novum Nano, it's the state of South Dakota and Christy Nome. We have also completed 6 nanotechnology STTR AFWorks research awards over the past 2 years. The next steps for us, we want to work with prime contractors and electronic manufacturers to be able to incorporate our memristor into new electronic platforms. We have truncated these use cases from a very large global evolution of electronics that has gone from tubes, transistors, resistors to now memristors. So this is going to be the next evolution of the stage of electronics. So we're looking to work with Lockheed Martin, Northrop Grumman, Raytheon, General Dynamics, Boeing, et cetera. We have made initial contact with Northrop Grumman's global supplier program sector, and we're very excited about that. So again, we've truncated all of the possible uses of electronics and memristor applications down into these 2 very specific use cases to be able to get some traction on this. There are many other applications in defense and in global commercialization. And key takeaways, Novum Nano is a proven performer. We're eager and ready to work with you. 8 technology patents issued, 6 AFWorks successes, close partner with School of Mines and Ellsworth Air Force Base. Please join us in the Novum Nano booth, where we have a lot more information, many documents. I'll tell you more about our team and our plans and dreams and desires. Thank you very much.
Fantastic, team. Opening up for questions from the group.
Just a quick question on how does to integrate this into existing systems. If you want to redo a Predator, for example, I mean, is it a plug and play type replacement, or does it have to re-engineer the entire kind of electronics platform?
So it is a process. If you're going to replace, multiple resistors with a memristor, you're going to have to redesign that circuit board, which is why we're looking for partners to help us, make that happen.
And we do have an interest from an Army customer that has a chip programmer partner that wants to work with us. And we believe that Northrop Grumman would be part of that team along with some other government agencies.
Okay, great, thank you.
And other research labs have expressed interest in some of the DoD organizations as well. Well, fantastic. There's some great materials that the team has in their booth, so go check them out afterwards. And I know that Greg and Craig would be happy to talk about use cases, as they said, for hours with you later. So take them up on that offer, hop in there. They can talk about memristors at length.
Thanks.
Absolutely. All right, we have the team from Polu Energy up next. OSU Battery Life, you are on deck. Perfect. All right, David, if you want to unmute yourself. I think you're muted, David. There we go.
Good afternoon and good morning, everyone. I guess you can see my screen all right, I guess. So I'm David Ma from University of Hawaii. We are a couple of years ago we started a new startup company called Polo Energy, based on a new technology we developed recently and patent pending. So we are working on we're focusing on energy and water security in the Pacific Rim. As you know, recently, especially the tension in the Pacific Ocean seem to be increasing, and we believe that the stability of the region depends a lot on the energy and water as the essential supplies to the military installations there.
It already happened.
Oh, I'm sorry. So the problem we're looking at is we're trying to recover the energy cost from the water diesel unit. As you can see that a lot of those places where you don't really have a lot of groundwater or isolated places, where most of the case where you will have to use water desalination technologies to actually get fresh water out of ocean water. But these technologies are really expensive in two ways. One of them is the high energy cost. And secondly, there's most of the cases they will need membranes to do the water desalination. And the membranes, there's a lot of concerns, of course, like fouling, durability, and things like that. So the water diesel has been a very expensive technology. And our solution is not trying to come up with a new water diesel technology, but rather we wanted to use our technology to recover the cost of the water diesel, especially using their byproduct, which is considered the brine, which is considered as a, there's a big issue regarding that, the dumping that brine directly into the ocean that could actually impact the local ecological systems. So that's basically what we're trying to do. Now, the technology we're using is called blue energy technology. And what is blue energy? So blue energy is kind of a new technology that extract energy or power, generating power from the mixing of two kinds of waters with different salinity gradient. In this case, we're considering the brine, which is really high concentrated ocean water, versus regular ocean water, which is relatively low concentration compared to the brine. Now, whenever you have a concentration gradient, and when the two kinds of water mix, then there's a so-called Gibbs free energy released through that process, and we can actually extract that energy and to generate electricity from that energy. So that's basically what I did, the basic rules of it, basic working principles of that. So the nice thing about this technology is that there's no moving parts, there's no membrane related. It's basically, we use nano materials, nanotubes, carbon nanomaterials, specialized, developed in our labs to achieve this relatively high power density solution. Now, if we use this technology in conjunction with the water desal unit, for example, as you can see here, the right is, for example, the portable water desal unit, and the brine generated from that operation would be pumped into our unit. And then we also use the regular ocean water as a low salinity, low salinity part. And then when the two kinds of water mix and then generates electricity that can be used for other purposes, or pump back into the system for water desal. And also because of the mixing, and then we kind of dilute the brine in a sense where you can actually discharge them into the ocean with minimum impact to the local marine lives. So right now we have a patent pending application. We have another provisional patent probably coming up pretty soon. We're looking, we have done some bench top kind of demonstrations, and we're looking to partners to actually scale it up to maybe start a pilot project somewhere with the military installations. With that, I
Awesome.
think we'd like to answer any questions we have.
Thank you, David. Open up the floor to questions.
This is a very intriguing concept. I'm wondering from an efficiency perspective, relative to the energy input that you get into a desalination process, how much of this do you think you could get back with your system?
Yes, the theoretical limit of this is actually is pretty high. We estimate probably we can recover about 20%. But of course, depending on the process of your water desal practice, right? So that 20%, well, I mean, the total energy cost can vary depending on the water desal technology. But I think I'm confident we can probably recover up to 20% of that cost. Then if we can achieve that, I think that's pretty significant.
Great.
Have you identified any operational end users or talked with any military, not customers, but people who or commands where this solution would be relevant or applicable? And if so, have you been able to tune it at all to their requirements?
Right. We haven't been able to really get connected with the military DoD agencies like end users per se. We have talked to some other, energy sectors, I think, but we haven't really had a chance to reach out to them. DoD partners.
Do you have a plan, or have you identified any to go talk to yet?
Well, not really, because we are really new, especially to DoD. So I really appreciate this program that actually we get exposed to a lot of DoD potential partners. We're seeking to see if it's possible, if we can establish some sort of connection, and then we about it, and then we can tweak our designs for a specific purpose.
Okay.
And if folks on the line have potential DoD connections I think would be interested, definitely stop by David's booth and pass them along those names. Wonderful. Thank you, David.
Thank you.
All right. We're going to turn it over to the OSU Battery Life team next. And then our final team, Zeta Energy, is on deck.
Okay, I think I got the unmute part going. What screen do you see my screen yet?
Yes, I would make that. We see your whole desktop. So I would make, there we go. Now we're good.
Is that good? Perfect. Fantastic.
Yes.
Good afternoon and good morning, everyone. It's a pleasure to be here, and being later in the deck is kind of fun because I've had a chance to hear all these other excellent things. And our team focuses on battery life. And the point here is that methods for predicting and extending life of batteries in real use, whether it be commercial or military applications, is actually quite a challenge. Battery degradation is unavoidable, and it affects the usable energy and power, efficiency and throughput. Eventually, it'll have an effect on emission success. So one of the things that I need to state up front is that we're a little different from all of the other presenters here, in the sense that we are not representing a startup company, but we are squarely within a university, big research universities with lots of activities. And out of this, of our activities in externally funded research in this university, we have created over the years, over the span of some 20 years plus actually, a battery energy storage research team that works from issues that go from materials to even a second life use of batteries. And collectively, we have over a century of expertise in research and deployment of batteries for various applications in ground and air vehicles. So what is the key here? We have a long experience of collaborating with both the private sector companies as well as government agencies. So in some sense, we're a little different from some of the other participants here. Although I've heard others who've had good connections with government agencies because we've done work with NASA, the Department of Energy, AFWorks, and the like. So over the past 3 years alone, we've done some $10 million worth of research programs in this area. What we're presenting here, which is the subject of this first cohort in the eMERGE program, is the ability to develop a battery life prediction tool that relies on a physics-based model on purpose that are all those complicated equations on the left-hand side, but we are able to use this knowledge into information and have demonstrated it across many different chemistries, energy system architectures, vehicle platforms, and end-use applications to essentially estimate and to some extent control and extend the life of batteries. The idea of these physics-based methods that we use is that we have developed ways to, using machine learning, data-driven methods, to develop a battery life prediction tool that can be rapidly adapted to different end users and applications. And I'll talk about applications in a moment. But the idea is that this deep connection between understanding the physics of the problem and understanding the data analytics and machine learning methods that one can use to translate these into rapidly deployable algorithms and systems is the strength of our team here. Let me give you some examples of projects. We are on the verge of completing a large program funded by NASA on electric propulsion with airplanes in connection with other partners, but our team was responsible for understanding the design of a safe, reliable, and long-lasting battery pack for a regional aircraft. We work with AFWorks on life cycle trace space analysis of a number of emerging battery technologies for UAM and all kinds of other advanced air mobility applications. And basically, we are focused in these projects on lifetime prediction, design of controls of the battery packs, and real-life diagnostics and prognostics of the battery as it is in use in a specific application. Let me give you a quick application example. Imagine you have a drone that needs to be deployed for a certain mission in foreign territory somewhere in a difficult place, and this drone may have been in storage for a period of time prior to deployment. How do we know quickly what kind of mission life we can expect from the batteries in this drone? This is just a simple-minded example of how these type of technologies could really make a difference in day-to-day mission execution. I wanted to also say 2 quick words on a current project that we're doing with a large automaker today. They have available in-house a very complex physics-based aging model of a battery. And what they're asking us to do is to see if it's possible for us to translate this physics-based model into something that can actually be deployed to estimate the state of health of the battery, remaining useful life, and current availability of power using limited data that would be available from everyday, day-to-day operation of the vehicle by a private customer, and adapt these predictions based on the history of the battery and on the current environmental conditions. This is just an example of how we are deploying some of our ideas in a real-world application. Now, as I've mentioned already, we are well-versed in contracting with government agencies and have done some work with DoD agencies as well. And we would be ready to deploy some of these solutions either directly with an agency of the DoD or through a contractor, we're also, and that's the engineering services side of this, we're also interested in continuing to do research to continue to advance these methods. So we're open also to any funded R&D opportunities. And
All right, Giorgio, I'm going to have us move to Q&A here in 1 second. Do you want to just get your last ask out there?
And absolutely. And we also have a continuing education program that can help train personnel in your organizations. Done. Thank you.
Fantastic. Thank you so much. And we'll open it up for questions.
So you covered a lot of ground. I'm just wondering, what do you think the nearest transitionable technology, battery technology that you have that you want to bring to market?
It is basically the ability, let's imagine that you have a particular use case. Let's use the drone example, right? And you have these drones that are deployed in different parts of the world with different ambient environments, right? And you would like to have a method whereby you can very rapidly understand what kind of mission life you have available under a specific condition to ensure that you have the ability to complete this mission, and to also determine at what point you would have to replace the battery that might be in use in that particular application. This is just an example, but the deployment of this kind of system, essentially developing custom algorithms that are fed by very limited data. The key in this is that you have some device and system that is already in operation and you only have access to limited local data. How do you translate that into operational information that will serve your needs?
Great, thanks.
Who are some of the optimal PEO, program executive offices or program managers that you've identified? Don't worry if you haven't spoken to them yet, but have you identified any optimal PEOs for this? Because it sounds like you've done a decent job of identifying end use cases for where this could apply. Have you been able to kind of take that to the next step?
Not yet. We recently submitted a proposal on this subject area to IC Works, which we don't know the outcome yet. So that is something that we've tried to do. We think that we would be very interested in exploring these. So we don't really have established a connection yet. Obviously, we're going to be in our booth, and we would like any kind of suggestions that we could receive as to how to move. We can imagine so many different end-use applications, but so that's why we're here. We're looking for introductions, I guess.
I mean, we have my friend and colleague Ian from Ohio State here as well. Sorry to put you on blast, Ian. I mean, it would seem that however they go by FLICMIC, Air Force Lifecycle Management, as well as is it out of Huntsville Army Future Vertical Lift that has the mission for at least soldier-borne sensor, this SBS program in the Army? I mean, they would seem to be two logical stopping points for this in terms of people to talk to you about how this aligns with their mission. But that's just off the cuff, having seen this deck here.
Yeah, and Ian, we've had conversations with Ian, and we will continue. Thank you.
Awesome. Thank you very much, Giorgio. Excellent presentation. With that, we are ready to move on to our final team here. Todd Foley from Zeta Energy, you're up. Giorgio, if you can just give up your screen share, that'd be great.
Yeah, just a second. Done.
Of course. Thank you.
Can you see the presentation?
It looks like it's loading on our end. There we go. Now I can see it.
Okay. How's that?
Perfect.
Okay, good. Thanks, everybody. Zeta Energy is a Houston-based company developing a game-changing lithium-sulfur battery technology. developed at Rice University and scaling now our Zeta Energy batteries are an immediate next generation technology that will disrupt the current reliance on lithium ion batteries. This key strategic breakthrough for us is that our batteries are abundantly available feedstocks, lithium and sulfur, and involve no difficult to acquire, expensive, or rare earth materials. And we offer our civilian and military customers a better, faster, cheaper batteries for a host of applications, and offer actually the US a strategic opportunity to, on a geopolitical basis, to lead in battery manufacturing vis-a-vis our global competitors because of our cheaper cost and reliance on abundant materials that are even available domestically. Our batteries can be used across the EV market, from advanced autos to a range of military vehicles. The key performance metrics in the EV market include, of course, longer range. Our batteries can go 110% farther and dramatically lower the cost by 50%. The cost for EVs, which is really an important breakthrough in reaching both the military and broad consumer markets. And due to the flexibility of our form factors and attributes of the technology, Zeta Energy batteries have applicability across all market segments, including serving the very important emerging renewable energy market. We also enhance the reliability, resilience, and performance of our power grid, and even a range of micro and consumer applications. For the nation's military, Zeta Energy batteries are 1/3 the weight. They're safer. We don't have spontaneous fires, which can occur in lithium-ion batteries, and we provide long storage of usable power and much lower costs. For the applications, for the potential applications include a range of military vehicles, drones, and even the warfighter, the individual soldier, providing a host of power needs critical to our nation's security and our warfighters. There's quite a bit of information on this slide, but as mentioned, our batteries are better, faster, cheaper, and have a number of key attributes. And it's largely to the game-changing chemistry in both our cathode and anode. In our cathode, we use a very stable and high-capacity sulfurized carbon material. In the anode, we have a very strong lithium metal bond that serves an important natural dendrite suppression, which has been a key problem in the lithium-ion batteries and is really the basic source of the fires and arcing that we might see in those batteries. Our batteries are faster charging, a charge rate of 6C to 10C, or they can be charged as few as 10 minutes or even less. The batteries are significantly more power by weight, 450 watt-hours per kilogram. They're longer lasting, more reliable and durable, with 2,000 cycles of charging and discharging. The batteries are, as mentioned, hold the charge much longer. Sitting idle, our batteries will only discharge at less than 5% even after 1 year. These are very important performance improvements relative to current battery technologies. Here's another slide that goes into more benefits of the technology. I'll just sum up by saying that not only, again, there's more energy and power and they're safer, but they're more sustainable. Like we said, we don't use any cobalt, nickel, or manganese. Our feedstocks are common, lithium and sulfur. The form factors allow us to have freedom in shaping the cells, which gives us a much greater market applicability. And we offer a host of applications. Here's a slide that gets into more detail on the cost reduction. And just safe to say, really, the difference really is the feedstocks, the materials we use in waste products that are abundantly available, whereas most other batteries are using very, very expensive and hard to get nickel, cobalt, and manganese and other materials. For right now, we just closed our Series A round of funding. We're moving into the Series B raised $70 million this year to support continued scale up of the technology. And we continue to look for private investors, as well as we're exploring partnerships with the U.S. government, DoD and DOE, which might be interested in the technology going forward. And there you have it.
Fantastic. Thank you, Todd. We already have a question. Keith, going to turn it over to you.
Sure thing. My question pertains to the 2,000 charges that you referenced on your slide. How does that compare to the existing number of charges? That's a little foreign for someone like me.
Well, that's actually, the cycling. I think
you said you pictured a soldier, and so that's 7 years if you get a single day's charge for one soldier, right? If he had something in the field that way, that's a pretty long time. Now, if you're able to get more than 1 day out of a charge, you're talking 10, 20 years for a soldier and one lifespan for one device with one application. I was just curious, how breakthrough is that technology compared to? Yeah,
it's very significant. I mean, it's a huge advantage, showing that the batteries are more durable, that they can cycle more often, more reliably. So that is a huge breakthrough. I think the basis of that really is the strength of the anode and cathode, and that relates to the chemistries of both. And just to get into that just briefly, again, on the anode, what's the game changer there is we use a carbon nanotube which allows much greater density and a tight bonding to the metal foil, which is a natural suppressor of dendrite formation, which actually leads to the degradation of the anode. On the cathode side, we use sulfur. Sulfur is in other past lithium sulfur efforts, the sulfur leaches, and you can see a yellow powder in itself. We actually changed the nature of the sulfur to a sulfur with a much stronger sulfurized carbon bond, which prevents that. Hence, that the battery itself, because of those components, are much more stable, long-lasting, and can charge and discharge more often and last longer.
Thank you.
Any other questions from the group?
Just on kind of test and validate, how far along are you in terms of validating those performance capabilities?
Yeah, we've been producing coin cells and pouch cells and have been testing them with the private sector and a couple of labs to verify these performances. Mm-hmm. And so far, all of the efforts that we're engaged in have met or exceeded our expectations. So we're pretty confident we'll continue on path to get there.
And what's a reasonable timeline to get to EV size cell? Not obviously there's multiple cells in that, but like to generate enough power to run an EV. How far off are you?
We don't think very far. This year, the investment will support the expansion of our pilot line, and so we expect to have pilot production by the end of the year into next year. We'll share those cells with key validators, possibly labs, as well as potential off takers, and even possibly using the government. And so we expect to have commercial product in as little as 2 years. So something in that rough time frame. So maybe even sooner, or roughly about that time frame, and scaling up to the next 2 to 5 years.
Awesome. Thanks. That's great.
Hey, just jump in with questions.
Yeah, go ahead.
Hey, Todd, great to see you. Eric Perrecka here.
Eric,
thanks for the
how
update.
you doing?
I'm doing tremendous. Hey, just curiosity, what is the form factor of these compared to something like a lithium ion? Are we talking, a multitude of small circular cells? Or are we talking something more like a lead acid battery?
We could do, we call them jelly rolls. We could do flat. We can do what we call in other shapes as well. That's due to the inherent flexibility of the chemistries again. And so we anticipate being able to produce a number of these, develop these number of form factors to kind of fit the use. So that's one of the important attributes of the technology.
Great. Thank you.
Awesome. With that, I'm going to stop our recording.